Hi everyone, this is Miss Ward. Tonight your notes are going to be on Circular Motion Unit Concept 4, discussing inertia. So, an object in motion resists change in motion. It comes from Newton's law, where we say an object in motion remains in motion unless acted upon by an outside force. With linear motion, we say that object has inertia. We've talked about inertia several times when dealing with linear motion. The greater the mass of the object, the more difficult it is to change its motion, and therefore the greater the inertia. There is a similar relationship with rotational motion. In this case, we talked about rotating inertia, or the moment of inertia. So each object has a moment of inertia, I, which determines how easy or hard it is to change its rotation, just like it is to change the motion of a linear object. An object with a large moment of inertia is difficult to stop or start rotating. Think of a merry-go-round once again. It's not easy to get that thing going. It's even harder to get that thing to stop because it does not want to change its motion. That's its inertia. Think of a meter stick. Holding a meter stick in the center, it's easy to rotate it back and forth very rapidly. If you grip the stick at the end and try, it is much harder. This is because much more of the mass is further away from your hand than it was before. Thus, the further an object's mass is away from the center of the circle, the harder it is to rotate. Moment of inertia can be calculated using the equation I equals mass times radius squared. Looking at a quick example, a basketball has a radius of 0.12 meters and a mass of 0.57 kilograms. What is the moment of inertia? Okay, our equation is inertia equals mass times the radius squared. Our mass is 0.12, our radius is 0.12, our mass is 0.57. Plugging that in, we get inertia equals mass of 0.57 times the radius of 0.12 squared. 0.12 squared. So we get 0.12 squared is 0.0144 times 0.57. Moment of inertia equals 8.2 times 10 to the negative third. And that's it. Make sure you go on, do your online whisk, bring any questions you have with you to class, and we'll have a short quiz covering this material. Have a great night.